In this, we are dividing complex fractions. So first, I'm going to change any mixed number to an improper fraction, or you can change any whole numbers to have the invisible one underneath. Just as a reminder, to change a mixed number to an improper fraction, I multiply the whole number in the denominator. 1 times 8 is 8, and then I add that numerator. 8 plus 7 is 15. This big division bar or big fraction bar represents the division, and we're dividing by 3/4. We've discussed how you can leave, change, change. Now we're multiplying straight across the top and straight across the bottom. 15 times 4 is 60. 8 times 3 is 24. I know that 3 goes into both of those, so I'm going to reduce. 3 times 20 makes 60, and 3 times 8 makes 24. I can reduce that again because both of those are even. 2 times 10 makes 20, and 2 times 4 makes 8. They're still both even, so I can continue to reduce again. 2 times 5 makes 10, and 2 times 2 makes 4. So our final answer here is 5/2. You can change that back into a mixed number if you prefer that format. Then go ahead and complete the remaining problems to finish up your fluency activity. Number 1 says to create a table, graph, or an equation to represent your assigned type of relationship. I'm going to assign you with proportional. You can create a table that has a constant rate, a graph that is a straight line through the origin, or an equation in the form y equals whatever that constant of proportionality is times x. A lot of times people refer to that constant of proportionality with the variable k. So you can pick a number for your constant of proportionality and fill it in to write an equation. In the next problem, we are going to answer questions related to the description that it gives us. It says Jonas is 10 years old and Lily is 8 years old. How old will Lily be when Jonas is 20 years old? Well, right now they are 2 years apart. That's not going to change as they age. They're always going to be 2 years apart. So if Jonas is 20, Lily is younger than Jonas, and they are 2 years apart. So Lily would be 18 years old. Is this a proportional relationship? Explain why. Well, let's see. If I divide those two, is it going to come out to the same unit rate? Well, 8 divided by 10. 10 doesn't fit into 8, but it fits into 80 exactly 8 times. Well, let's look at 18 divided by 20. 20 doesn't fit into 18, but it does fit into 180 9 times. Those decimals are not the same. So this is not a proportional relationship. Let's also think about it in terms of a graph. On a graph, it needs to go through 0, 0. Well, that would mean Jonas would have to be 0 when Lily is 0. but they're 2 years apart, so that's not possible, meaning this can't be a proportional relationship. Create a table or graph to justify your solution. So we could create that table if we had Jonas's age and Lily's age. Well, when Jonas is 2, Lily is 0. When Jonas is 10, Lily is 8. And when Jonas is 20, Lily is 18. So this doesn't go through the origin. If we were to graph it, when Jonas is 2, Lily is 0. And when Jonas is 10, Lily is 8. It does make a straight line, but that straight line does not go through the origin. It would have to go through this point in order for it to be proportional. For problems 3 through 10, determine whether the situation is proportional. Explain how you know. For any relationships that are proportional, find the constant of proportionality. Number 3 says the grocery store sells apples for $1.25 per pound. This is a proportional relationship because each pound of apples is $1.25, meaning that the constant of proportionality is 1.25. It has a constant rate of $1.25 per pound. Number 4, a do-it-yourself car wash charges $2 plus 25 cents per minute to wash your car. This one is not a proportional relationship because there's a fee of $2 in addition to the cost per minute. So it is not a constant rate since the $2 at the beginning would put us through the point 0, 2 rather than 0, 0. Five, Abdul walks a quarter mile in every 1/12 hour. This is proportional because he walks the same distance in every chunk of time. To find that unit rate, we need to divide the miles per hour. So miles divided by the time. Remember, we leave, change, change. 1 times 12 is 12. 4 times 1 is 4. But 4 fits into 12 exactly 3 times. So that constant of proportionality, also known as K, is equal to 3. He walks 3 miles every hour. 6. Ava uses 3/4 of a bag of fertilizer for every 1/5 of her lawn. This is also proportional because the amount of fertilizer is the same for every 1/5 of her lawn. To find that constant of proportionality, we need the fertilizer per lawn. Leave the first fraction, change to multiplication, and flip that second fraction over. 3 times 5 is 15. 4 times 1 is 4. So that constant of proportionality is 15/4. If you want it as a mixed number, 4 times 3 makes 12. Then to get to 15, we need 3 additional. 12 plus 3 makes 15. So you could write it as an improper fraction or as a mixed number. But that constant of proportionality is equal to 3 3/4, or 15/4. A package of 96 diapers costs $24.27. A package of 72 diapers costs $19.44. To determine if this is proportional, we need to divide. So if we divide the cost per diaper and the cost per diaper on this one, if they come out the same, then we will say they are proportional. But if they're different, then they are not proportional. So 24/27 divided by 96 is 0.2528 approximately. And then 19.44 divided by 72 is 0.27. These are not the same, so they are not proportional. A gas station sells gas for $2.79 per gallon. This one is proportional because every gallon costs the same amount. So that value, that constant of proportionality, is 2.79. Each gallon costs $2.79. 9. Noor wants to bake a batch of trail mix. One batch, which is 4.5 cups of trail mix, contains a 1/4 cup of raisins. Every batch is going to use the same amount, so this is proportional. To find that constant of proportionality, we need to divide. We want the raisins per batch. Or raisins per cup of trail mix. We want to change this to an improper fraction. 4 times 2 is 8, plus 1 more is 9. Leave, change, change. 1 times 2 is 2. 4 times 9 is 18. No, 4 times 9 is 36. Reduces to 1/18. So 1/18 is that constant of proportionality. Remember, we use the letter K to describe the constant of proportionality. Number 10. So he owns a greenhouse and wants to buy carrot seeds. For $59.95, she can buy 1 pound of seeds. For $26.95, she can buy a 1/4 pound of seeds. Well, we see here that for 1 pound, it costs $59.95. So if we wanted to figure out the cost per pound of seeds in this second scenario, we would divide $26.95 divided by 1/4. That would be the price per pound. Well, if we use that leave, change, flip method, we'd flip the fraction over and it would become 4/1. So that's basically the same thing as multiplying by 4. Five times 4 is 20. 4 times 9 is 36, plus 2 more makes 38. 6 times 4 is 24, plus the 3 makes 27. 4 times 2 is 8, plus 2 more makes 10. There was 2 decimal spots in the question, so we need 2 in the answer. But you can see that it is not the same as $59.95, so this one is not proportional. It does not have a constant rate. In this scenario, 1 pound costs $107.80 But in this scenario, 1 pound costs $59.95. Now you're going to try and create your own. See if you can create a scenario that is proportional and one that is not. If we have a written description, we can look at the unit rates to determine if it is proportional or not. That is the end of this lesson. Go ahead and check back for more coming soon.